Hello guys, welcome to our class. For our today's class, we're going to be looking at reflection of light. We have already introduced the light waves, and we have seen how shadows are formed and all that. So today we're looking at reflection of light. So please, under this topic, we're going to talk about reflection of light, then different types of reflection. We'll also look at laws of reflection and reflection in plane mirror. The image formed when plane mirrors are inclined. Then we also look at rotation of plane mirror, use of plane mirror, then we'll now solve some problems. So these are the areas we are going to look at today. So please, as I've always said, get your writing materials ready so that we can go straight to our topic for today. Okay, and please, if you have not subscribed to our channel, what are you waiting for? Please subscribe to our channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. This is Nobleman Science Tutors Online. You can reach us through the WhatsApp number that is showing right on your screen. That's okay. So I remain Otobo Michael, and you are welcome to our class for today. So please, if you are ready, we are ready for you. Let's go. Reflection of light. So when we say reflection, we are talking about something that is coming back to you, right? Something that is coming back to you. So reflection of light or coming back to you, or something that is being thrown away from something, yeah. So it's just like when you throw a ball against the wall, the ball will fly off. So reflection of light is the throwing off of incident rays from a smooth or polished surface, e.g. a plane mirror. Okay, so when light is incident on a plane mirror, that incident light is reflected back from the plane mirror, or it is thrown back from the plane mirror. Okay, so it is that reflections that comes out of the plane mirror that also enables you to see. That is what also gives us the sense of vision, because you can only see an object because that object is reflecting the sun ray to your eyes. That is where you can locate the image of an object that you are viewing. So that is just what reflection of light is. And then there are some terms that we need to know when we are drawing the ray diagram to represent reflection of light. This is a typical ray diagram for a light that is incident on a plane smooth surface and then it is reflected. So this ray that is striking the surface of the mirror or the smooth surface is called the incident ray. Then the one that is being thrown off is a reflected ray. Okay, then the angle between this perpendicular line to this reflecting surface is known as the angle between this incident ray and the perpendicular line is known as the angle of incidence. Then the one between the reflected ray and the normal or the perpendicular line is known as angle of reflection. Alright, then this angle between the reflecting surface and the incident ray, or between the reflecting surface and the reflected ray, the angle is known as a glancing angle, and these two angles are equal. The angle is known as glancing angle and they are equal. So the one between the incident ray and the smooth surface and the reflected ray and the smooth surface, they are equal and they are known as glancing angle. Okay, so that is the glancing angle. So now we'll look at the laws, the types of reflection, and then the laws of reflection. So basically, we have two types of reflection: regular reflection and diffuse reflection. So regular reflection occurs when parallel rays of light beams on a smooth reflecting surface and they are reflected in the same direction. So you can see the regular reflecting surface, and then these are the rays of light and they are reflected out of it. So this type of surface is okay, this type of reflection is known as regular reflection. But the one in which the rays of light they fall on a rough surface that is not smooth and they are reflected out in different directions is known as diffuse reflection. So e.g. reflection from a piece of paper or from the surface, the surface of a piece of paper is not smooth. So incident rays on the piece of paper will be reflected out in different directions. So such reflection is what is called diffuse reflection. But the one that happens on a smooth regular surface is known as regular reflection. Okay, so now what are the laws of reflection? That is what we want to discuss now. The laws of reflection, using the diagram that we had before, the laws of reflection states that the incident ray, the reflected ray, this normal, at this point of incidence, this point of incidence, all of them, they are on the same plane. So this is the plane they are in. So this incident ray, reflected ray, and the normal, they are all on the same plane. That is the first statement of the law of reflection. Then the second law states that the angle of incidence is equal to the angle of reflection. Finish. So these are the two laws of reflection. Okay, these are the two laws of reflection. Now we'll look at the image formed by a plane mirror. When we are talking about reflection, mostly our mind goes straight to a plane mirror. Okay, so what are some of the images that are formed by a plane mirror? Typically, this is a diagrammatic representation of the image formed by a plane mirror. So if, assuming this is the eye of an observer, right, and this is the object that the observer wants to view, he will see the image at this end. He will see the image at this end. So if you look at this image, you find out that the distance of this is your mirror. The distance of the image from this mirror is equal to the distance of this object from the mirror. So the image of a point formed by a plane mirror is far beyond the mirror as a point is in front of the mirror. This is one major characteristic of the image formed by a plane mirror. Another characteristic of the image formed by a plane mirror is that the image is laterally inverted. What that means is that there is a change around the image of the object from side to side. So simply put is that when you stand in front of a plane mirror, your left hand will be your right hand and your right hand will be your left hand. That is called lateral inversion. Right? If you stand on a plane mirror, your right eye will be in your image, your right eye will be your left eye and your left eye will be your right eye. That phenomenon or that observation is what is called lateral inversion. Okay, that is what is called lateral inversion. So these are some of the characteristics of the image formed by the plane mirror. The image is formed at the same distance as the object is in front. Then the image is laterally inverted. So generally speaking, for an image that is formed by a plane mirror, the image has the same size as the object. That is one. The image has the same distance behind the mirror as the object is in front. The image is laterally inverted. The image is upright, that is standing erect, but the image is visual. It cannot be formed on a screen. That is why it is not possible for you to form that image on a screen. You can only see the image, but it cannot be formed on a screen. Okay, so these are the characteristics of the image formed by a plane mirror. Very, very important. Take note that a visual image cannot be formed on a screen, but a real image can be formed or cast on a screen, like the image of a pinhole camera. That one can be formed on a screen, but that of a plane mirror cannot be formed on a screen. Okay. Now, if you have two plane mirrors that are inclined at an angle, there are numbers of images that can also be formed by such arrangement of mirrors, and that is what we want to treat now. So when two plane mirrors are inclined at an angle, how many images are formed? Now, when the two plane mirrors are placed parallel to one another, the number of images formed, they are uncountable. So we say the image formed is infinite. Yes, the image formed by two plane mirrors placed parallel to one another, the image formed are infinite. You have infinite numbers of images, but when they are inclined at an angle to one another, and the angle is a whole or is an exact factor of 360 degrees, this is the formula that we use to find the number of images formed. Number of image formed is equal to 360 all over theta, which is the angle of inclination minus 1. But if the angle of inclination is not an exact factor of 360, then the number of images formed will be 360 all over theta. That's all. So please take note of these two formulas. They are very key, because we'll use them to solve some problem there. So check your jam question and wire question. We see where this formula can be applied to solve some problems on light waves. Okay, so these are the formulas to use to solve for number of images formed when two plane mirrors are inclined. Then when a ray of light is incident on a plane mirror and then it is reflected, there is a deviation. Instead of the ray to go straight normally, it is now deviated to give you the reflected ray. Now that angle of deviation is what we're talking about here, and the angle of deviation for this plane mirror is this angle. Okay, the angle of deviation is this angle from the angle of reflection down to this ray. All right, and from mathematical calculation, this angle of deviation is equal to 2 times the glancing angle, and that is equal to this, equals to 180 minus 2 times incident angle, or 180 degree minus 2 times reflected angle. Don't forget that the incident angle and the reflected angle, they are equal. The angle of incidence and reflection, they are equal. So I can either write it as 180 minus 2 times angle of incidence, or 180 minus 2 times angle of reflection. They are the same. So depending on the question that you are given, you know which of this formula to apply in order to solve your problems on angle of deviation for a plane mirror. What of if the plane mirror is rotated? When a plane mirror is rotated, the angle between the incident ray and the reflected ray, the angle between the incident ray and the reflected ray is given by 2 multiplied by incident ray plus angle of reflection, all brackets. Why the reflected ray only is rotated through angle 2 theta. So when a plane mirror is rotated through angle theta, the reflected ray will be rotated through an angle 2 theta. Then the angle between the incident ray and the reflected ray will be 2 angle of incidence plus angle of reflection, or multiplied by 2. When you add them, the summation of these two multiplied by 2 will give you the angle between the incident ray and the reflected ray. Okay, so please, these simple formulas you need to take note of them. Know that when a plane mirror is rotated, the angle of reflection is rotated through angle to theta. When a plane mirror is rotated through angle theta, the angle of reflection is rotated through angle to theta. Then the angle between the incident ray and the reflected ray is given to this incident ray plus theta, incident angle plus angle theta, all added together, then multiplied by 2. Alright, so these are some of the uses of plane mirrors. They are used as looking glass. They are used in periscope for seeing round corners. Okay. They are used in kaleidoscope for creating color patterns in textile industry, and they are used in sextants to locate altitude of the sun. Basically, in everyday life, this is what you use the plane mirror for. You use it as a looking glass. Then they also use it for periscope. Periscopes are like they use them to see round corners. But the most use of plane mirror is this particular one, being used as a looking glass. That is the major use of plane mirror. Okay, so I hope we have learned a lot on this. We want to solve some problems on plane mirrors so that we can know how to apply some of those few equations that we have discussed so far. So this one says that a ray of light strikes a plane mirror at a glancing angle of 50 degrees. Calculates the angle between the incident and reflected ray. Okay, so for this, my diagram will not be too perfect, but I just want to use it to explain what this question is so that the answer will come out readily. So you pardon me, I'm drawing with my hand, so it will not be perfect, but you should use it to understand what the question is saying. Okay, so this is your reflecting surface, then this is your incident ray, and then this is your reflected ray, then this is your normal. I said sorry about my drawing. It's your incident ray, this is your reflected ray, then this is your glancing angle. Okay, so I hope that brings out the point that the question is saying. So the question is saying that the angle between the mirror, or the angle between the incident ray and the mirror, which is the glancing angle, is 50 degrees. Based on our discussion before, we have said that the glancing angle, they are equal on both sides. Okay, so this angle is perpendicular, so which means it's 90 degrees. So from here we can say that angle of incident will be equals to what? To be equals to 90 minus 50. 90 degree minus 50 degrees, so that gives us 40 degrees. Then for the reflected ray or reflected angle is also equals to 90 degree minus 50 degrees, so that also gives us 40 degrees. So the incident angle is 40 degree, reflected angle is 40 degrees, so the angle between them will be equals to 40 plus 40 degrees, 40 degrees plus 40 degrees. Okay, so that, which means that the angle between them is equals to what? 80 degrees. So I think that is clear. So that you see the reason why I had to draw it, so that you will not be imagining it. You draw it and then it becomes very clear for you to understand. I hope this one is clear and simple. Thanks. Let's go to another one. So this one says that a ray from a fixed object is incident on a plane mirror at an angle of 20 degrees. If the mirror is rotated through angle 30 degrees, by how many degrees will the reflected ray rotate? So we have said that when the incident angle is constant or is fixed, and a plane mirror is rotated through angle theta, the reflected ray will be rotated through what? Angle 2 theta. So this one is just simple to be rotated through angle 2 theta, reflected ray. So that gives you 60 degrees. So this one is just direct and simple, just like that. There's no further story to tell about that question. So that's just it. Okay. This is another question. A candle is placed between two mirrors which are inclined at angle of 72 degrees. How many images will be observed in the two mirrors? Fine. So we have said that the number of images n is equals to what? Is equals to 360 all over theta minus 1. So theta is 72 degrees. So n will be equals to what? 360 over 72 minus 1. Okay, so by the time you work that out to be 5 minus 1, so number of images formed will be equals to 4. See, so this formula, once you know how to apply them, your answer will just come out readily. I don't think this one should take more than 30 seconds to solve. You don't even need to writing it down if it is jam. So thanks. Okay. So guys, this is your test your understanding page. We solved a lot of questions. So just try your hands on this and then you see how you understood what we have discussed so far. So thank you so much. This is where I'm stopping for this particular class, and then we hope that you are benefiting greatly. So before I go, please guys subscribe to our channel, give us a like, give us a thumbs up to encourage us. That's okay. Also share this channel with your friends. Invite your friends so that they can also come and enjoy what you are enjoying. This is Normal Science Tutors Online. I remain your physics online tutor, and you can reach us through the WhatsApp number that is showing right on your screen. Give us a shout. If you have any challenge, just paste it there. Give us a call. We'll respond. We are here to assist you and to make you very, very good in physics. Is that okay? So thanks for your time, and we really appreciate you for being with us so far. Thank you, and we hope to see you in our next class. Thanks.